Well, just basically how to work in a factory. Like, they make sure that you are ready for life, and if you ever want to get a factory job, you'll know how a factory operates already, because we've already been on the floor multiple times. You were required to buy steel-toe boots, they gave you glasses, they teach you all the safety.
Yeah, they teach you everything you need to know, the basic things anyway, before you start. Hop on something, do something. They're very safe, and like we wouldn't hop on a mill or a lathe or anything without knowing the basic information we need to know. Usually we just job shop first the first couple of days. You know, they explain stuff, what they're doing, why they're doing it.
So right now we're doing what they assign us our junior year. So right now we're learning all of the stuff that we need for next year. Next year will be we'll be considered interns here. So next year we'll actually be helping out on the floor, making stuff for the business. We learn all sorts of stuff. Like we're going to learn like robotic programming. Like right now we're doing drafting, so we're making up a dice holder project. We're going to learn how to machine out that project. We're also going to learn how to program the robot for that project. And the list just keeps going on. Right now we're working on drafting, so we're learning up on how to sketch something. So if a customer calls in, tells us what they want, we'll be able to sketch it up. And then we'll be able to see that part being made out on the floor.
The first year we got to experience a lot of different things, sort of welding, electrical. We've done programming on computers, worked on CNCs, mill lathes. Yeah, so last year was a lot of basic training, just like learning basic knowledge such as tools, like learning how to mics and calipers, and just we got a little bit of everything just so we knew. We weren't so confused when we walked out there. We had to like start from rock bottom and work our way up. And last year we had teachers, were in the classroom for most of the year, them teaching us certain things like it's more of a, I would say that they do a good job of teaching, because they show us. It's not like a book work. We have teachers in the room, hands-on, teaching us stuff that we need to know. So I wouldn't say it's book work by any means. And this year, for 6 weeks, we have to, I went to shipping, I went to quality, and right now I'm in CAD programming and design. So, and then after this, I'm pretty sure we get to go into an area that we're interested in the last couple of years.
There's that. We did quite a bit of PLC programming, which is programming, so you hook wires up to a bunch of like different things like motors and lights, and then you can hook it up to a PLC and then run off one switch and operate all those different things. It's just like a different way of wiring something. But if you want to design that, you can do that. We also, on computers, we did PLC programming, we did print drawings. We've learned how to draw prints, read prints, make something out of those prints, make a piece of paper actually come to life on a motor or a dice block. And one of those basic things of engineering is actually drawing it on paper and putting it out on the floor and seeing if those people can actually make what you put on paper. Because sometimes they can't, or it might be, or the print might be wrong or something compared to what can be done.
You get a really good insight on what opportunities are out there that you just have to take advantage of. So here at APT, when you leave, you'll have your journeyman's card that you can use that about anywhere. Pretty much says that you're qualified in doing this and you've been tested in it. It's kind of like a degree saying that you know what to do. Another thing is you get a better insight on what's more like in factory work, like here at APT, what more there is than just being out on the floor doing stuff. There's also office work, there's drafting, there's all sorts of stuff like that. If they like our work ethic and stuff, they'll allow us to be accepted into their apprenticeship program our senior year. So at our senior year, they'll pay us to work, like after we graduate, they'll pay us to work our 40 hours a week, and then they'll also pay for us out of their pocket for us to go to Northwest State for college 2 nights a week. So that'd be really good. So you're working, making money, and you're also getting your college degree at the same time.
I oversee the quality management system. ISO 9001-2015 is a version that we are certified to. It is a system that helps to ensure the quality of the product, that we are meeting the requirements of the customer and our own internal requirements and procedures. If in the event that we make something that is not to print or not to the requirements of the customer, then we respond to that and do a corrective action, that kind of thing. I tried to work with the students to give them real-world experience, a little bit of information about what we do in the field of quality, some of the documents and many of the procedures and the activities we perform in the quality department in order to ensure good product goes to the customers. And you can see the range of making parts first time out with really good quality, everything's to print, as to where some customers have some really tight tolerances and difficult requirements to meet, and the sales department has said we believe we can make that, but there are challenges along the way, and sometimes you fail and you don't realize what some of those requirements of the customer are until you've actually made the product and shipped it the first production order to them. No, most of the time those parts are scrapped out and that product is recycled. We try to keep that to a minimum. As you know, it's costly. Scrap rework and all that is costly. You put some money into the product, that you want to avoid that at just about all costs. Sometimes you can't anticipate everything that can go wrong in manufacturing, and some of the times the simplest products you're trying to make can be very difficult. There are things you can't foresee. You try to anticipate, you try to prevent. We do a lot of preventive measures to make our product good first time off, make the tooling as robust and as good as it can be to make that product. And whatever is the process, we have procedures in place to ensure that product is good. And we do a pretty good job most of the time, but there are times and we try to learn from those failures and try to prevent those things from happening again. Oh, there's a wide variety of reasons why something goes wrong and the product is not to print. It can vary as much as even the machine warming up. It's not warm when you first come in and start the machine up in the first of the day. And as the machine warms up, some of the dimensions, they change. So sometimes you actually have to make part of your procedure is that the machine cycles for a period of time until it gets to a certain temperature before you even try to run the material and make the product. It's as simple as that. A few 10,000ths of an inch can make all the difference in the world in meeting your customer requirements or failing to do that. We have what we call quality plan, where we have check sheets and prints on the floor and steps in order how they're supposed to measure and ensure the product is correct to the requirements of the customer, and most of those are found on a customer print.
Yes, currently right now I am teaching the second year students, and what we do with the second year students is we actually bring them through a step-by-step process of our CAD software. So we actually teach them how to virtually model different parts. So with the virtual modeling, we can get as detailed as you want. We can go as far as actually applying motion to different mechanics that are within the design. We can do part profiles, we can do contours, we can do, basically we can essentially do a real life part on a computer. There's a couple different directions you can take it. So one is for a CNC machine. If we use a CNC machine, they're actually taking the virtual part, inputting that data into the CNC machine, where then the CNC will extract that data and then create the part automatically. If we have a manual machinist create the part, then they actually are taking dimensions that the engineers provide them, and they're taking those dimensions and making the part manually. We do not, as far as engineering goes, we just provide the data to the programmers down on the floor, and then they will take that and input that into the CNC machines. The program that we give the students gives a really good foundation if mechanical engineering is a path they would like to take. They'll be ahead of any college students when it comes to learning 3D software.